As per the answer to the question, how security appliances do encrypt the malware content whenever they are actually in action, straightforward actually to answer this question, there is no encryption to be happening whenever we are talking about a security appliance to detect the malware. Yeah, they are not security appliances, they are not done to encrypt the malware content. They are done to detect, to prevent, to yes, detect and delete something like that, but not to encrypt. Maybe there will be a scenario via which we encrypt the content in order to forbid them, but the main purpose of the security appliances is to detect, prevent, and beyond all that, there will be an action to eliminate the deployment of the payload the malware is holding, but not to encrypt the content. Not to encrypt the content. None of you has answered the question. The 7 of you, none of you has answered the question properly. Keep going on. Actually, DOS attack from where we stopped. Small briefing. Then after we continue, DOS attack. It's a very famous, actually, point-to-point attack via which we eliminate the server from being accessed by legitimate requests. That's it. It is a network sort of attack, kind of a behavior over the network, via which we see legitimate requests put into a queue, waiting for a resource to be delivered, without hint that the resource is being consumed already, but consumption in terms of being occupied, not being deleted or deleted or let's say blocked. Sorry, nothing damaged. It's only that the service is being occupied, and that's it. It is serving other parties. So there is a long list, a long queue that the legitimate requests have to wait in. That's it. That's the denial of service concern, the main purpose behind. It is a network actually attack mainly because it has to be done remotely. We cannot have actually DOS attack from a service to another, but while technically we can do it, but it is not the purpose. The main purpose is to do a remote attack. And this DOS is one of the very famous remote attacks attackers do perform over the networks, and mainly over the public networks. We talk about the internet. The DOS actually mainly it happens why? Because of the consumption of specific and given predefined network devices, network resources, talking about the bandwidth or the operating systems themselves that they are controlling the network, which are the server based mainly, not only, and the applications that they are actually serving network activities, something like that. So it is to consume the network resources. Right, let's stop. The ping of death is one of the very famous. Ping of death is one of the very famous attacks, and it is done to flood this ping of death. It is done to flood. It is utilized to flood a network tool, network device, and put him into a state that he cannot reply to legitimate requests. Thus, we talk about flooding ping command. It is a network. It is a ping of death mainly. It is the main purpose behind the ping of death. Ping of death. We say death. Why? Because the network device will be put into a situation that it cannot completely reply to any legitimate request. So he is dead. He is like to be a dead device. This ping of death, it is not to be happening in a specific network, but across networks, whatever the networks are. We'll come to this graph just in a while. The ping of death and the ping in general, it is a process that comes and it happens over the network which does not have a port. Means as the network serves, the pinging does not have a port to control. What does it mean? Any network serves to be controlled. We just control the port number, or the port itself, generally speaking. Then after we are controlling the serves. The ping, no, it does not have a port to control. but it belongs to the protocols responsible for helping and doing communications over the network. Communications here in general, we just send any sort of a message. The ping, what does it do? It probes destinations. It probes destinations. Hey, destination, are you alive? That's it. That's what the ping do. So it is sort of a communication. It is sort of a message. When the probe has been sent, it's sort of a message being sent. And once the ping is being successful, actually, once the ping is being successful in flooding a network device, the ICMP protocol will be put into action in order to declare that the resource requested to send a reply to or response to legitimate requests, that the resource request is being occupied. This is an error message. It's a sort of an error message. And this is actually to be happening because it's a must that the service owner has to reply. It is a must. It's not yes, I'll reply or not, or maybe or depends on the server mood. No, it's not like that. Any request has to have a response. It depends what is the response, but there have to be a response. So there is a process to happen here in the service provider, and after the process, the response has to be submitted. From the scenarios via which we succeed, also or attackers succeed in doing those attacks or in doing finalizing the DOS attacks, is the spoofing. Spoofing of what? Here we talk about spoofing. Spoofing, we know it's an active attack via which a man in the middle to attack a communicating parties, A and B, to alter the communication process, to cause a device redirect, to cause a network redirect, to cause the messages to be falsified. Listen to me here. When we talked at that time, when the spoofing activity, it's a scenario via which we see an active attack. The active attack might be causing device redirect. Device redirect. We define this, chapter number 5. Network redirect. Message falsification. Message here, we talk about the packets, or the message itself, or the group of packets. Falsification. A sends to B, hey, I'm coming. No, A sends, I'm coming. B receives, hey, I'm not coming. I'm not coming. Message has been falsified. It might happen, absolutely. This is due to the spoofing activity. What we see here is the address spoofing. Address spoofing. It falls in what? It falls in the case of the device redirect. Device redirect, via which we see that the destination has been changed, or the source, mainly the source identification has been falsified to be another device. Thus, we talk about the device redirect, and here is the source address spoofing. The B to respond, it will not respond to the legitimate device. It would respond to the falsified device, which is the attacker's device. And because of this, the attacker uses his device, or his falsified device, which is trusted by the destination, to send a huge number of packets to put the device into a stuck state. Stuck state. He's not able to respond to any other legitimate requests. The backscatter traffic is a scenario via which we trick the users, or we force, it's not we trick, we force the users of resources, network resources, to use specific path to pass through in order to reach the resource or reach the destination. In order to use the internet, for example, here from, let's take the example of the University of Lisbon network, our campus network, internal network, local network. Any users from inside the network that wants to use the internet, for example, they have to pass through server number 1, named server 1, and S1, for example. This is a choke point. As per the security techniques, it is a choke point, so the service is delivered through that point only. Everybody has to pass through that point. And thus, it causes a backscatter to the traffic. What does it mean? It means that everything that happens on the channel is controlled. Is it controlled? Yes. And thus, any trial of attacking through that path, it can be captured. How? Because that path will play the role of a honeypot. What does it mean, honeypot? It tricks users to say that this is the resource they want. If they are attackers, they will follow the path because there will be no security or weak security scenarios. Everybody gets in there, will be captured. If he is an attacker, he will be caught. If he is a legitimate user, he will pass to the next level. Backscatter traffic. So thus there will be actually control of all the traffic. Any communication happens in between A and B over the network. Any fully means all the communications. There have to be a 3 handshake process before. What does it mean? It means any device communicates with any other device. There have to be a 3 handshake process happens before any communication starts or any resource sharing starts. What is the 3 handshake process? This is an indication of that this device is trying to communicate with this one, and this one, the service provider, has to indicate that he is ready to receive. What does it mean? There is a probing message to be sent, said SYN message, SYN, synchronization, SYN, synchronization, SYN, synchronization, synchronization. It's a packet to send to the destination service provider. The service provider, once he receives the SYN, he has to reply with a SYN EC. SYN EC, synchronization acknowledgement. Hey, I received, I'm here, I received. Synchronization acknowledgement. I received. Thus, this source, once he receives the SYN acknowledgement, the synchronization acknowledgement, he will acknowledge that he will start communicating. Acknowledge, SYN acknowledge, SYN acknowledge, send, receive, send, receive, send, receive. Is it clear?
Yes,
Ryan,
please.
is it clear? Huda, is it clear?
Yes, Mr. Clear.
Great. This process here, this is the legitimate process. Yet there is a SYN flooding process. What is it? What is it? Here it is, SYN spoofing and flooding, both of them, via which we make the server, in order of sending the SYN acknowledgement response to the sender, no, it would be sent to a falsified device, which is the attacker device. It's falsified device, spoofed. Why? Because the SYN has been sent, intercepted in between, and the ID has been changed. Then we talk about the SYN spoofing. SYN spoofing. The response from the server will not be to the legitimate computer. No, it will be to the ID where the SYN is identified, which is the attacker's device. The acknowledgement here. And the communications, all of them, they would be actually happening with the attacker's device. So in conclusion, since spoofing is a context via which we attackers do falsify the ID of the source over the SYN packet, There are different techniques, but even though all of them, they are to falsify the ID of the sender. Means the sender that starts with a SYN, he has to identify himself. Okay, this ID would be actually falsified to make the service provider communicate with the new ID, which is the new IP address, which is the attacker's IP address at the end. Senders devices, they might actually acquire why they did not receive the SYN acknowledged, but one of the scenarios is that the device is not alive if there is no response. So they will say that the device is not alive. They will not claim that there is an issue. The sender, when the sender sends a SYN and he does not reply the SYN acknowledgement, he will say that the service provider is asleep. It's not available. It's not online. So you not do anything. The context of the flooding, remember that the flooding means actually to bring a service into actually a full state. He is not able anymore to reply to legitimate requests. He does not have any capability, even by chance, to reply to legitimate requests. Types and models of flooding, mainly they are related to services or network services. When we say actually services, means we talk about a protocol that runs on the network level. Amongst those protocols, the ICMP, the Internet Control Message Protocol, the one we presented earlier. ICMP is one of the protocols that actually plays the role of helping devices to communicate with the different levels. Amongst of the communications is to indicate that there is a service or there is no service. ICMP. This ICMP works on the networks connection based, means wired networks, wired computer networks. There is another scenario via which we see the same communications happening but on a wireless network. So what is the service controlling those wireless communication scenarios? The UDP, User Datagram Protocol. The UDP is one of the very famous protocols, but controlling the wireless networks. Wireless networks. What does it mean? It means the pinging and the probing of the destination. It is a scenario via which we recognize connection-based networks. It's not a scenario where the network is based on a wireless scenario. Did you understand this point? This is belong to the network, to the layer 4 transport layer from the OSI model, and this one, it belongs to the network layer, the layer number 3 from the OSI model. So this is network and this is transport only. It does not take care of the network. What is the path from where to go? No, it does not care about that. It cares only it has been received or not. Spoofen and Fluden. Now it is clear for you, for sure. Spoof to falsify, flood to bring it to a dead state, spoof to change the direction, the destination, whatever. Flood to bring it to a stuck mode. I believe it's very clear now for all of us. Yeah, so this is the definition we given about the UDP, which is actually a protocol that runs on the, it defines the ID, yes, based on the identified devices, but on a wireless network, Why? Because actually it is one of the technologies that attackers do follow. Why? Because there is no acknowledgement of reception. Once the communicator sends a packet, there will be no acknowledgement that the thing has been received. Thus, the attackers have the benefit of this task, of this point, of this criterion. No SYN acknowledgement, no SYN ECK. From the same scenario, we talk about the distributed DOS attack, which we via which we see one attacker, one destination or one victim, and a list of compromised devices, which is given the name botnet, made up of list of zombies. So an attacker attacks a target, and this target is one device, the attacker is one device, and the attacker would use a list of compromised devices, and each compromised device is a zombie. All of them, they are zombies, and those zombies, they are generating one botnet, network of robots, botnet. They are only doing what this attacker wants. They are acting according to the commands of the attacker. Thus, we talk about the DOS, DDoS, distributed DOS. Why? Because this target here, this victim, is being attacked by many devices at the same time. With the same scenario. Distributed denial of service. From the activities of the DOS attacks is to compromise the bandwidth, the network bandwidth. So the network bandwidth means actually the full dedicated space to communicate in and out, to communicate flow in and out from a device is being compromised, to compromise the bandwidth. Whatever the request is. So here, this bandwidth here, actually, it is dedicated to all the flow. The downlink, the uplink, the voice-based communications. All of them, they are covered under the title bandwidth. But there are specific applications that they use specific portion from the bandwidth. Given the example of the VoIP. The VoIP actually, or the communication over the, for example, the computer networks. If we want to generate a voice communication solution over a computer network, we will be able to do that, that's for sure. And we will use specific protocol, which is the SIP. And this communication would happen specifically on a dedicated portion of the, with a dedicated space size and the bandwidth. So there might be a specific DOS on that specific path, only for that specific application type. Means the DOS would happen only for the voice over IP communication solutions only. Other applications, they would run very fine. Here we talk about an application-based bandwidth attack. Application-based bandwidth attack means that the communication dedicated to that specific application is being compromised. So dedicated to a specific application. In the example here, the VoIP. Why the VoIP? It does not consume any computer network. If it provides a VoIP as a service, not the full bandwidth would be, let's say, compromised. No, only small part from the bandwidth will be dedicated to this application, to this voice over IP application. Okay, DOS for a specific application, it can happen here for that specific kind of applications to compromise the bandwidth for that application only. Other applications would be able to run and just communicate over the network still. Is it clear here? Okay, without any delay here, we talk about the reflection of attacks, another kind of scenario via which we see the DOS in action, the reflection of attacks here via which an attacker would read what are the services delivered by, or the services available in an intermediary network device to spoof them. To spoof them means to spoof the device, to spoof the network path, or to spoof the communicated content, or something like that. So the attacker will see the intermediary devices, what are the services available there, and he will try to mimic them in order to flood the destination with a huge number of the same services available on the intermediary devices. The intermediary devices means they are recognized by the attacker, sorry, by the target. And those targets, if they receive any services from those intermediary devices, they would accept. Thus, the attacker would mimic those intermediary services in order to spoof, yes, here to succeed to spoof. After that, he will be able to send those services to the targets, but with a huge number. So thus we talk about the reflects. The service is being reflected. The service does not. The attacker does not have the service, but he's mimicking the service. He's saying that he has the service. Reflection of attacks without delay. Yes, here it is. So the attacker will recognize what are the services available here in order to attack the attacker, to flood. Remember the word flood. The attacker with a list of services. There are other let's say combinations and other variations of the same thing. But at the end of the day, there is a service to be mimicked. There is a service to be regenerated and used as a real one. A reflection of attack. Or reflection attack. Okay, actually, the amplification is another scenario via which we see is something similar to the reflection, but here we are seeing serves to be amplified. What does mean amplified? Means we have actually a web server, for example, and the web server has an application. This application is legitimate and can access a dedicated, let's say, network source locally. Okay, an attacker recognizes that, so he would succeed to, yes, reflect the service provider. To reflect service provider, first of all, means you'll do the same scenario here, to reflect the service on the intermediary device. Yes, here it is. And then after, he will spoof again. He will spoof again by sending a huge number of requests from the same service provider to the target, to the victim. Here we talk about the reflection attack still, but we are not seeing it as a reflection. We are not talking about the reflection here, because the reflection will happen at this level. But we are talking about the number of requests to be sent to the target. The number of requests, usually actually a web server will send one response or one request to the destination. Here, no, there are numerous and big number of requests to be sent from the same service provider to the destination. This is due to the reflection, yes, and also to the success of making this reflection. And we talk about amplification. We do not talk about the reflection. The reflection is to be utilized to do the attack. The attack is the amplification. Any questions, please?
No, Mr.
Okay, those are actually scenarios via which we saw different kinds of DOS and DDoS attacks. But the question comes here, if you don't have the question, actually how to prevent. The prevention is coming through different security approaches. Starts from the intelligent activities, how to settle the network, physical architecture. We talk about subnetting or the virtual networks. Beside of that, the prevention is better than the detection. Means there have to be actually a chance to prevent attacks better than detecting attacks. The context of the prevention means that there is something to happen before the attack starts. Detection, we talk about something already happened, but there is a filtration. There is a sort of discrimination, categorization of the content in order to specify that this is a malware or not. The attack already happened. Detection, the attack is in action. The attack is in action. The attack is in action. Okay. Trace back actually the source of, we are going to make an analysis, malware analysis, to see if our framework is already vulnerable or there is a malware already residing in our network. Past. We detect the DOS or the DDoS. In this scenario, we are going to scan the environment for chances of detecting available malware. So we talk about already injected malware, and already they did their job in past. Another purpose is that if the attack happens, there will be an event handler. Attack reaction after the attack means actually here, if there is an event handler to control the trigger. An event handler to control the trigger means a specific kind of attack, it is controlled. If it happens, there is an action to happen. Full stop. So if you hear your name, just say yes, please.